Relays and contactors, diagnosis and wiring. Welcome relays and contactors, how to test, diagnose, and wire them in real-world HVAC systems. If you want to become a confident air conditioning technician, you must understand these control components because they're the heart of electrical switching. Let's start. What is a contactor? A contactor is a heavy-duty switch. It controls the high voltage going to components like the compressor or fan motor. When the thermostat calls for cooling, it sends 24 volts to the coil of the contactor. This pulls the internal contacts closed and allows 240 volts to flow through to the compressor or fan motor. Contactor equals low voltage in, high voltage out. What is a relay? A relay works the same way, but it's usually for lighter loads or multi-speed circuits. You'll often see relays inside the air handler, used to energize PSC blower motors, electric heaters, or secondary controls. You send 24 volts to the coil, and it switches either 120 or 240 volts on the other side. So both relays and contactors work by the same principle. A small control signal moves a magnetic coil, which closes or opens a separate electrical path, where you'll find them. Contactor in the outdoor condenser, switching the compressor and fan. Relay in the indoor air handler, switching the blower motor or electric heater. How to test a contactor, step by step, turn off power. Always. Inspect the contacts. If they're pitted, blackened, or stuck, replace the contactor. Check coil resistance. Set your multimeter to ohms. Measure between the two small terminals, usually marked A1 and A2. Typical resistance, 10 to 30 ohms. If you read OL or 0, the coil is bad. Apply 24 volts manually. You should hear a click and see the contacts pull in. If nothing happens, bad coil. If it pulls in but the motor doesn't run, check the high voltage circuit. How to test a relay. Turn off all power. Visually inspect it. Many relays are clear plastic. You can see if the contacts are stuck. Check the coil resistance the same way. Use jumper wires to apply 24 volts and see if the relay closes. Use your meter to test continuity across the contacts, with and without coil power. If the coil works, but the contacts don't pass power, replace the relay. Common relay wiring example. PSC motor. Let's say you're replacing an ECM motor with a PSC motor. You'll use two relays, one for cooling and one for heating. The G wire, blower call from thermostat, will energize relay number 1. The W wire, heat call, will energize relay number 2. Each relay has 2 terminals for 24-volt coil, 2 terminals for 240-volt line load. When energized, it closes the circuit and sends 240 volts to the correct motor speed. Don't forget to wire the run capacitor in parallel with the motor. Extra tips from the field. Always verify coil voltage. Some are 24 volts, others are 120 volts or 240 volts. Contactor coils burn out from power surges. Carry spares. Never reuse a stuck contactor. It may stick again. Label your wires before disconnecting. Watch for dual contactors, double pole, especially on heat pumps. Warning signs of a bad contactor or relay. Buzzing noise but no operation. Motor tries to start but cuts off. Burned, blackened, or stuck contacts. Thermostat calling but no power reaching the motor. Melted terminals or insulation. If you see any of these, test the coil, replace the part, and restore operation.